Hi, welcome back to the Cosy Sound channel and part 8 in the series all about my Project XII DIY modular analog synth. Let's just stop the sequence running. And in this episode I'm going to be looking at a utility module that I use in just about every patch I put together these days. It's actually a buffered multi. In fact, it's two buffered multis. One of them is like just a buffered patch bay where you can stick all sorts of CV signals in. So you've got like one in and three out. But the other one is actually a gate buffer, or buffered gate, whichever way around you want to say it, which basically will take gate signals and then you can put one in and then you will get three balanced gate signals coming out. I'll talk a little bit more about the detail and I'll show you the circuits, and then we'll have a look at how I use them in a patch similar to, well, it'll be the one you just heard at the beginning there. I'll show you where everything's going and how the multi allows that to happen. But first of all, we'll have a look at the circuits for these. If we start with the buffered patch or buffered multi, this design is taken from the Modular in a Week series. The link is down in the description. And basically it's just using op-amp buffers to take a single input and give you up to 4 buffered outputs. I've only put 3 on my system. I thought that would be enough. Sometimes it is, sometimes, yeah, I wish I'd probably gone for the 4. I could easily add one anyway. So yeah, if you go to the Modular in a Week series, follow the link I've given and you will actually be able to see the circuit diagram. I took that circuit diagram and I put it on a stripboard layout, and the stripboard layout looks like this. So yeah, really simple. It's a quad op amp, 4 resistors, and as you can see I've only wired up 3 of the outputs, but I could stick an extra jack socket on the 4th output and have 1 in and 4 out. Very simple design and very useful for distributing CV signals. Okay, so that's the buffered multi, or buffered patch bay as I've called it on my system. So what about the gate buffer? Well, if you watched the episode I did on, well, I did a series actually, there's a playlist on kick drums that I've been putting together, and one of them was the passive kick drum, the drumish module, again something that came from Modular in a Week series. And when I built it, I couldn't get the beat step to trigger it. Now the reason for that is that the gate signal out of the beat step is probably only around about somewhere between 4 and 5 volts, so it's not very high, and it wasn't high enough to trigger what is a passive circuit. Now if you go and watch that video, what I put together there was a comparator, which is again uses an op amp, but basically it looks at what the input is, and once it reaches a certain level it will give you an output which is just below the supply rail to the op amp. Now Nathan Ramsden put together basically a gate buffer. This is what his circuit diagram looks like, and as you can see on that circuit diagram, you can actually simply add additional outputs with a simple resistor and a jack socket. So what I've done, I've taken that design, I've put it onto a stripboard which looks like this. And on my version I have the gate signal input going into the comparator end of it, and then the outputs, I've got 3 of them wired up just through a resistor and a jack socket. So again, a very simple circuit, but as you will see, it's very useful. In fact, the multiple gate buffer, that's the one that is probably the most useful when I'm putting patches together. So there you go, your very useful modules. I've put put them into one single module on my system, as you'll see in a moment, and yeah, really simple. So let's have a look how we would use buffered patchbay and a gate buffer. Okay, here we a little more close up. This is the utility module, and top here where the purple lead is going in, that's the input to the buffered patchbay, and then there's 3 outputs, but I'm just using 2 of them. So the first one is going down to the dual VCO, although I'm only triggering one of the VCOs in there, and then the second one is going down to the single 4046 VCO. So I've got a CV input coming from the beat step, and then that CV input is shared between 2 VCOs. You can kind of choose just about any CV signal you want, and then for the gate signal, the pink lead is the gate output coming from the beat step. So if we take the top one, which is the blue lead, that's actually putting a trigger onto an envelope module, and then the CV from the envelope module is going to the CV input on a Vactrol, and the Vactrol has got the output from one of the dual VCOs, and then that just goes to the mixer on the end there. The grey gate signal, the grey lead gate signal, is going to the CV input on a low pass gate. The input to the low pass gate is coming from the single 4046 VCO, and the output, the red lead, is disappearing off to the mixer. And then I'm using a third gate output, so I'm using all 3 of the outs on that, and the third one is going into my simple clock divider, and the output from the clock divider is going onto the trigger in on the kick drum module, and then the output from the kick drum is going to the third input on the mixer. Now you could do multis by using something like this, one of the old little starfish multi things. The problem with that is that there's no buffering, and if you've got signals of differing strengths, then the strongest signal could actually start to interfere with the lower strength signals, and also that would not get round your gate voltage levels, because obviously you're just sharing the voltage, so chances are you're going to lose it rather than gain it. So there's good reason to go for buffered patches and also the comparator gate. So yeah, I've got literally 1 CV output and 1 gate output from a beat step controller, and when I hit go on the beat step controller, you will hear a sequence playing, and you will hear how that one sequence is being shared across the modular system and produces something that sounds like this. So the clock divider LED is I need to stick a bigger resistor on that. I mean, that thing is just kind of, particularly if it goes dark, it's blinding. But at least you can see that it's triggering, and you can see the trigger on the low pass gate, and you should be able to see, where did I send the third one? Oh, it went into the envelope. I've got nothing on the envelope to show me that the envelope's triggering, but the output from the envelope is going to the Vactrol, and you can see the Vactrol's triggering. It's a bit dim, but you might be able to see that that's one of the CV triggers on the dual VCO there. I've got no visual indicators on the single 4046 or the kick drum. But what you can hear there, all of that relatively complex sound is coming from 1 CV signal and 1 gate signal from my sequencer. And the rest is just how you share it. Let's change the attack on the envelope there. Take it back down again. So there you go. Two very, very simple circuits. Very cheap and easy to build, but immensely useful in a modular system. So I've given you everything you need to go on. Yeah, have a go. Build your own.